like to tell you about this journey about which speakers like Chef Gill and Pavanji mentioned in terms of the kind of impact it is creating over time. It has not happened overnight, of making food computable. So let me tell you about that journey and where we are reaching, and touch upon the most important question that we are asking in today's symposium in a humble fashion. Can a computer think like a chef? That's what we are trying to ask. I am because I eat, and chefs like to say I am because I cook, and all of us cannot survive unless somebody cooks for us. So cooking is an essential act that we indulge as human beings on a day-to-day basis. And this act of cooking is something very, very unique to humans. No other animal cooks, no chimpanzee, no panda cooks. So we are rather special. Apart from having other abilities such as language, we have this special ability of cooking, which makes us what we are. To an extent that it has been argued by Richard Wrangham in his book, that cooking is the thing which makes us human. If you ask this question about what is so unique about human, then cooking is one of those things which is rather unique and makes us human, what we are. However, like it was mentioned by Pavanji, that this food and cooking seems to be one of the central points which is making us what we are, which is an obese society on the verge of becoming diabetic. And it has become an epidemic both in India as well as across the world. Right? So question is, can we think about food such that we can look at a vision by 2050 where we are going to face 10 billion people? How do we feed these 10 billion people nutritious food, tasty food, healthy food, and hopefully sustainable food? Because otherwise the earth cannot sustain if you were to feed such a large number of people. And that is where, standing in IIIT-Delhi amongst data scientists and computer scientists, my vision is that of looking at data as a possible solution for understanding, answering, solving these questions that we are looking at food and nutrition. And while doing so, we make food computable. So you might wonder, what is it that I mean by making food computable? So let me explain that to you in a bit by bit. We are looking at different aspects of food: tradition, culture, history. Recipes are part of it that are being passed on from generation to generations over centuries, if not millennia. The taste aspect of it, the flavor aspect of it, the nutrition aspect of it, and finally the health aspect of it. Certain ingredients have good and bad effects on us. Can we get quantifiable information about it such that it can be documented? It has happened earlier in different cultures, including in India. Many texts like in Ayurveda, for example, mention about the effects of food on body. However, in today's modern science, if we can capture this information in a systematic manner, we should be able to come up with ways by which we can address this question around food, nutrition, health, and sustainability. And for that, I present to you computational gastronomy. This term, as was mentioned earlier, was coined well within in my lab. I did it and we have been using it for a while now, popularizing the term, because until you name it, you don't know how to describe it. So we have to find the right phrase to explain what do we mean, what are we doing in my lab. So computational gastronomy is a blend of food, data, and computing. In a popular parlance, may I say, is a blend of food and artificial intelligence to some extent, trying to find ways, coming up with applications around food and different aspects of it. So very briefly, let me tell you how it all started without spending too much time. Way back in 2014 and 15, I started with this small idea of looking at network of ingredients. It's called the flavor graph or flavor network. And by doing so, we were trying to find out what are the data available in a manner that we can apply algorithms on it about recipes, ingredients, and the flavor molecules of the ingredients. And we realized that hardly anything is there. Then I realized that there is hardly anything done in a data-driven manner about food at all. And that was A, my opportunity, and B, a threat. In the sense that if you want to sustain as an academician, which many of you know, you need to work in trendy domains, publish papers, get citations, which is why and how you are recognized. Shall I do that and do my in silico drug discovery, or shall I take the path which seems to be rather exciting but extremely risky? I took the second path. I said, okay, I think this is an important problem, let me try handling it. And we started gathering this data which was unavailable. And that is where we started with initial thought of looking at Indian food and what is so unique about Indian recipes, given the context of previous work which was done and published in Nature Scientific Reports about the food pairing in the world cuisines, which was done with a relatively shallow data. So we started looking at Indian recipes, collecting them like a data scientist would do by scraping the web and finding out what are the recipes and ingredients in them, and looking at the flavor molecules in a limited fashion that was available. And India, chefs here know who practice Indian cuisine and recipes that has a long history, diversity of food and recipes. So we had to capture all of this information, which is what we did with a limited data. 2,543 recipes scraped from the Dalal's website, which is a very well popular website for Indian recipes, and their ingredients, around 193 of them, and their flavor molecules, a few hundred of them, close to 1,000. And did what is called as food pairing analysis, which I won't get into the details. But the idea is to find, are there certain patterns in way the ingredients are put together in Indian recipes, which makes it so different from that of other cuisines. That's what we did, and ended up coming up with what is called as the culinary fingerprint. Something which uniquely identifies with the cuisine, tries to tell us about the uniqueness and the identity of a cuisine. And we found that spices are the most important elements. They are the fulcrum, may I say the molecular fulcrum of Indian recipes. We showed it with data, statistics and mathematics. And when we did this and showed that the spice is the taste of India, I was gleefully thinking it's such a wonderful thing that we have discovered. And chefs told us that, gentlemen, we already know that. Professor Bagler, we already are aware that spices are of course important in Indian recipes. But as it happens in science, the beauty of this, answering this simple question, what is so unique about Indian recipes, we say spices, is that we did it in a mathematical and statistical manner, which is intuitionally known, capturing what is known by mother and chefs who are sitting here, and capturing using a mathematics was a beautiful stuff, may I say. Alright, that's what we ended up doing, and found that spices are taste of India. And to my surprise, by the way, I was working and doing what is called as in silico drug discovery, very hot stuff, trying to come up with drugs using computers, and probably it's considered, even now it is considered a very hot field where you might end up making money. But I left that and started working on this, and I realized that all of a sudden, none other than MIT Technology Review picked up this article, reviewed it for us, like wrote a small popular article on it, and highlighting it as an emerging technology. So I was pleasantly surprised. And very soon, it became a trending stuff on Facebook and all other social media. Way back in 2015, I still remember the day, 4th of March 2015, my computer was like blipping continuously, telling me that somebody is quoting you, noting you and marking you. So that was a beautiful stuff when I became a small star from science. And not every scientist gets this opportunity, so I was lucky enough to get that opportunity. After that, we got a lot of mention across the media and mentions done in variety of popular houses, including highlighted as a pioneer of this area, and of course, science magazines like Royal Society of Chemistry highlighting our work as part of their Chemistry World magazine. And importantly, industry was quick enough to identify the relevance of this topic even back in 2015 and 16, and they started approaching me, and I realized that here is my opportunity, like Pavanji said, of making a little money probably. But of course, that was not what was driving. What was driving is that this is my opportunity to make an impact on the world, to change the future for decades, if not centuries to come. That was what was driving me. And that is where, in the last 7 years, to cut the story short of the history, we have been doing what we have been doing. Building databases, creating algorithms, and something unique and novel, playful stuff, and something which is valuable. All of that we have been building. So we have built recipe repositories like RecipeDB, Flavor DB, 118,000 recipes from across the world, 75 countries and roughly 24 regional cuisines. Flavor DP, the world's ground truth when it comes to flavor molecules in the ingredients. Spice RX and Diet RX, which is about the health aspect of ingredients, spices and other ingredients. Prediction of taste, and Ratatouille, the algorithm which is generating new recipes, almost challenging the intuition of a human expert. That's what we are doing for the last 7 years. And in this process, we have touched upon different aspects. I'll run you through those aspects which we have been dealing with. One, we're looking at the cultural aspect of the food. At the end of the day, food is a lot about culture, anthropology, history, geography, climate, religion to an extent. All of these have played huge role in impacting what we eat, how we eat on a day-to-day basis. So we need to capture that information. Taking the structured data of recipes, remember this database is not just another recipe database. It's a structured database wherein all important elements of recipe, title, ingredients, quantity, unit, form, such as chop, peel, process, utensils, etc. Everything is captured using the natural language processing, the tools of computer science, which we have built and published papers on those, capture those, provide it as a structured relational database, which further can be searched using intuitive queries. Show me all kind of recipes having cheese but not having onion, has calories between 200 to 300 kilocalories. Such complex queries can be answered by using this database, for example. And of course, we have mapped it with nutritional data, whatever was available, to come up with the nutritional information. The other thing that we did is to look at, hey, how is Italian cuisine related to Indian, or Indian is related to Mexican cuisine? Can we find out that answer? For that, without getting into the technical nitty-gritties, we define the identity of a cuisine, the culinary fingerprint, using the item set mining algorithm, and thereby define what makes Indian cuisine so unique in terms of what it uses, which ingredients it co-uses, and what it doesn't use vis-a-vis the world. Similar to that, other cuisines. So all these cuisines, we related them in this so-called multidimensional space, hyperspace, to look at the relationship between them, how similar, dissimilar they are. And by that, we could come up with a beautiful anthropological story, history. It's a detective story of looking into the history of food and cuisines, where we're trying to understand how are cuisines related to each other. And we found a beautiful tree, which we called as the world cuisine tree. And this is not very different, by the way, if some of you can think about, like a world language tree. Languages are also related to each other in terms of structure, grammar, phonology, etc. Right? So that is what this captures, by the way. Of course, we are refining it further, but this tells a beautiful story of what has happened for last so many years when it comes to food and cooking and recipes. The Flavor DB, another database that we have built. And using this information of flavor and recipes, remember I told you that earlier analysis was done with a very, very shallow information. Our idea is to make it deep and make it structured. We did both for recipes and flavors. And having done that, we can now find out culinary fingerprint not only for India but for the whole world. That's what we did. So we looked at all the regional cuisines, 24 of them, all the countries that we had information for, 75 of them, and found out their culinary fingerprint, what makes them so unique, what then makes them so separate, special, different from the rest of the world. And these are culinary fingerprints of the world. This paper, by the way, done with a summer intern, Navjot Singh, who worked with me for a while. Extremely interesting and curious characters, may I say, those students who work with me. And this paper was published, presented for the first time in IIIT, International Conference on Data Engineering in Paris, and it won the Best Paper Award. Oops, we said one more wonderful thing that has happened in the journal. So this story ended up becoming big. So this was about looking at culture, tradition from a data-centric perspective. Then we wanted to look at the taste, nutrition and health aspect of it. And for that, we had to relate this in a quantifiable and a scientific manner, not hearsay, not something which is documented but not evidence is not available for that. And therefore we looked up scientific literature. PubMed and Medline, these are resources from the US federal government, which is publicly available for all of us. We collected this data and related in terms of food, clearly identified food and a disease as per the medical dictionary, the medical subject heading, and the relationship between them, positive, negative relationships. And we try to understand this, given the fact that most of us are aware that oftentimes this can be very complex and confusing. That egg is good for you, but not good for you. Another news article saying so. Similarly, some other ingredient which is good for you, and some other article saying, newspaper article saying it is bad for you. How do you make sense of this? So we put together all of this data. Initially, starting with spices, 165 culinary herbs and spices, and their health effects. We integrated using this text mining algorithm that we have built, which is itself on the top of name entity recognition algorithms, to create spices and their disease associations called spice arrays. And of course, given the fact that the ginger is useful to you, good for in a certain disorder because of the phytochemicals which are in it. So we had to combine it together. Not one or two, but anything and everything that is reported in ginger, garlic, coriander, and all spices like that. And when we created this tripartite information of herbs, disease associations, and chemicals, here's a beautiful resource for us to mine it, asking interesting questions. If I have this disease, which spice might be good for me based on the evidence? And which molecules in this spice may be responsible for what it is good for? So all of this can be mined in a systematic manner. Then we said, why only spices? Let's take the whole repository of what is available to us as we call it kitchen basket. Ingredients like lentils, dairy, spices, vegetables, fruits, all of this around 27 odd category of ingredients across covering total around 2,200 odd ingredients and their disease association. Of course, this is a huge data. So this is the old stuff. However, we have 90 years data collecting 38,000 research articles. Don't forget, there will be at least 500 publications, PhD students which have graduated out of it, probably more than that maybe, right? So huge information that we are gathering and connecting it with food, disease, chemicals, and genes. Okay, trying to do that. One link is missing right now, but everything else that is shown here in yellow is all there. This is called diet. Again, available for public consumption for non-commercial purposes, and we are making it explorable. People can take it, try to understand things. And again, in the same direction of health and nutrition and taste, we went all the way up to the molecules level and asked this question: why is it that I feel the taste of bitter or sweet? We can also ask about umami, salty, and sour, but we start with these two, which are diametrically opposite tastes. We have evolved to like sweetness because of the calories that it provides us, and dislike bitterness because most of the food ingredient, naturally available stuff is bitter and is poisonous at the same time. But at the same time, today, we need to understand the molecular correlates of this. That's where we collected the data of molecules typically from the food ingredients and their taste, which is either bitter or sweet, categorically available, built the largest repository of this, and applied tools of artificial intelligence, machine learning for classifying them. Given a molecule, can I predict whether it is bitter or sweet? And this publication, which again was created into an interface so that food and especially the sweetener industry can use it for mining molecules which are of desirable taste. That's what we did. And further, we asked this question about how sweet is that? Given a molecule, is it sweet at the level of 1, 10, 100, or a million? Because sweetness can vary at a logarithmic scale, exponential scale, which has to be measured in a logarithmic manner. So we again collected this data, which was not being made publicly available, made it publicly available, built models for predicting this using again machine learning regression models, and have recently published to predict the sweetness. The tool is also available, which you can scan and use it if you wish to. So this is one resource we are making available for better public health. And what dish? So one of the projects that we have been working for a while now, with a large number of teams which is growing over time, wherein a mobile app with which you can do the food logging and capture the information of the dishes that you are eating, map it with the estimated nutritional content, such that, let's say for example, you can measure where do you stand in today's daily calorie consumption based on your height, weight, age, activity, and gender. And can you tell you about what you may and may not eat? Of course, this was a huge scope for improvising, making it personalized, and And of course, we want to cover the whole world. We are now covering India, stand at 61 popular dishes. We want to make it 100 very soon, maybe 500, and go to the world level also. This has huge implications. Those of you who are business minded can quickly think of what ways this can be used, how it can be exploited, and what better utility it can bring to population at large. Can we play? In Cozy Lab, the complex systems laboratory, we also try play. Alright, so we try to make fun games. So there are many ways that we are working on it, but the popular example which is already been highlighted in this symposium is Foodle, which is a twist on the Wordle, which is one of the most popular games which is running on the internet. What we have done and are improving is to create the most exhaustive dictionary, culinary dictionary, and its ontology, relationship among them. Okay, how are they related to each other? And nudge, a Nobel Prize winning concept about how do you make people do what you want them to do by small changes. So can we make people play games? Because those of you who play Wordle, actually after getting up in the morning, the first thing that you want to do is that, hey, let me play my Wordle. My daughter does that by the way. Okay? I want to finish my Wordle today. And if she is not finished, she'll be like restless the whole day. So can we make people restless to play a game such that at the end of the game we can say nudge into nutrition, health, which is what the public policy like FSSI, Government of India and world over governments are trying to do. Push them in a direction to make life better via food. And this is available at this place. Right now, in a beta mode, we'll be improvising it very soon. Come back and check it again. Building the community. Towards the end, I would like to tell you that I started alone, but people started coming, joining me, and we started creating a community out of its own. And this is what has been happening over a time in this lab, where we have built databases, algorithms, and excitement. Excitement so big that I'm launching a company out of it. It's happening. It's a startup that is being launched for generating novel recipes which are tasty, hopefully healthy, nutritious, sustainable, price conscious. Can we make that? We are working on that. That's what is happening in the lab, and the services that we are creating as a part of this work via the company as well as the institutional support we are already making available, which is why Alan is here, which is why Rishabh is going to be around here, and which is why many people are approaching us to right now, even already now we have more than 1,000 requests for getting services in a commercial mode. We are doing that. Symposium, it's a building community aspect. Everyone sitting here is interested in food one way or other, and we are building a community out of it to portray a data-driven picture of the food which has been missing so far in the narrative across the globe. Students, most of you are sitting here, some of you are already in this frame by the way. How can you make computer scientists and data scientists who would like to join Google, Facebook, Meta, all these big companies, or serve for multinational companies to think about food? The biryani that they eat, can they think about it in a systematic manner? So can they eat biryani, think biryani, and code biryani? That's what we're trying to do through this community of students, which I'm really proud of having, which is what even Pavanji mentioned, that it's this young lot which makes me younger than what I am. And I'm not too old by the way. We are helping the data science community further. Some of you may not know, by building what are called as Kaggle challenges. Young students who are working in computer science, data science, they want to take these challenges. So we are putting up challenges. How sweet is that? This data and right algorithms submitted will grade you and will tell you who's doing very good, right? And we'll learn in this process. Which dish is that? Predicting the dish given the ingredient. Is it, this is for dish, the what dish, where we are trying to predict which dish. Is it paneer butter masala, or is it rice, or is it paratha, whatever it is. Molecules, is it sweet or bitter? And which cuisine is that? Given a bunch of ingredients, can you tell me with what confidence, is it Italian or Indian? Can you predict that? And there are applications of this. So we are building Kaggle challenges. And of course, Python is a popular language which data scientists use. We are building a library, now being called GastroPy, thanks to my students who have worked on this project, wherein we are trying to build a whole library which the world can use, the data scientists can use, the Googles and the other companies can use, which to build applications out of computational gastronomy. That's what we are doing. And of course, dissemination. Over the last 7 years, I've delivered more than 250 talks, including TED Talks. One is coming in the next month, telling the future, data-driven future of the food, how to revolutionize food landscape via computational gastronomy. And of course, I love reading books, so I'm writing one. A popular science book, which is tentatively called as Bite, double meaning, Bite, which is computer science bite as well as food bite, telling the story of the data-driven history of food and digital science of food. The last thing, in 5 minutes, and then we'll go for tea. Can computers cook? How many of you have seen this movie Ratatouille? Wonderful. So you know this journey of a rat trying to move into a kitchen and trying to cook. And Chef Gustav in this movie says that anyone can cook. We said, let's make it a little dramatic. Can a computer cook? That's what we are asking. And in that context, we have already, again, we do what we preach. So we have developed algorithms based on natural language processing, about which my PhD is a scholar. Once he will be talking in the afternoon, technicalities of it. This algorithm has been published again in the IIIT conference. Couple of research work, including one in Poland, a very prestigious natural language processing conference in computer science. We have published, and this algorithm is now available for you to play. It's a primitive algorithm which is available there. We are obviously improvising upon it as we talk about it. And then this question, which is very notorious and provocative: can a computer think like a chef? Now think about it. These gentlemen who are sitting in front of us, we are having a cumulative knowledge of maybe centuries of cooking together. Now it is daring to say that computer can actually capture this knowledge, intuition, skill. Okay? But let me do that for a moment. And ask this question: can a computer think like a chef? Or Chef Manjit Singh Gill. He was gregarious enough to give this permission to use his name and picture for this very, very notorious question or provocative question. So thank you, sir, for doing that. And we have asked this question and are trying to answer this, and while doing so, other young chefs like Chef Sanjay Thakur, who is going to be there in the audience, Chef Wali, who also agreed for using their name and picture for this, and as I mentioned earlier, President of World Chef, who was he found it so interesting and intriguing that he said, okay, why didn't you create one for me? So Chef Thomas Gugler, he said that, okay, let's make one for me as well, and I did one to recognize all these people who are wonderful chefs themselves, experts, and I'm going to do more for many other chefs, which is inspired by this cartoon from India, which says that somebody called Chacha Chaudhary, a cartoon character, can actually think faster than a computer. So we are asking this question: can a computer be better or faster than Chacha Chaudhary? So we have built this tool, Ratatouille, as I mentioned, and we would like to validate this because it's a very simple question. Come on, you are telling me that your computer is spewing out recipes, titles, ingredients, and recipe instructions. How good is it? Have you tried it? That's the most important question, pertinent question, right? So yes, towards that, the first thing that we are doing is this. Following the question of Alan Turing, can machines think, which he asked way back in 1956, which is the foundation of artificial intelligence. By the way, we are trying to ask this question in the context of food and cooking. Can a computer think like a chef? That's what we are doing, and tasting these recipes through a Turing test, which I don't want to get into the technicalities, but essentially we have built a framework where you log in with your mobile. A chef will be able to log in with their mobile. It's an invited taste that we are doing, where they will go through a recipe like the one which is shown here, exactly like this. Look at the recipe and rate it. Is it fake or real on a scale of 0 to 5? And then, of course, we'll sit back and do the analysis about how well our algorithm, which is generating recipes, is able to create a text which looks like a recipe, reads like a recipe, and surprise, surprise, fools the chef into thinking that it's a real recipe. Can we do that? By controlled test, real stack and computer generated recipe stack, flashing it randomly and figuring out how well the chef or expert is doing. And using the metric called false positive ratio, for example, we can identify how well we are doing. So this is going to come out very soon with the help of course, all of you chefs who are possibly going to contribute towards this agenda of trying to test the algorithm. So we have followed this whole logic that I mentioned earlier in this process. So this is ratatouille, which I mentioned earlier as well. And the proof is in the pudding. So eventually we need to cook it. So these filtered recipes, which are going to come out of this whole process, obviously we would like to cook them. Again, we need help from maybe Institute of Hotel Management's culinary institutions and chefs, of course, to play this game and see how well the computer is able to do. Can we improve it? Okay, that's what we are trying to do and create AI-driven recipes. Way back when I was in IIT-Delhi, there was a joke that was played on me that now you will start cooking recipes. Looks like I have reached a place where I actually can cook recipes and maybe start a restaurant. I don't know how many of you have seen this movie called Blend It Like Beckham. And on that line, I'm proposing in a playful manner that maybe I can create a restaurant called Blend It Like Bagler. Let's see whether we can do it or not. On a fundamental level, thinking about recipes is what we have done. And I believe that there is a structure that Pavanji mentioned that I stole his idea. But I've been thinking on the lines of Noam Chomsky, imitating his logic, and also learned from Steven Pinker's book, Words and Rules. Could not sleep for 3 weeks almost, and created this whole idea of generative grammar of cooking, structure of cooking itself. And textbook material it has not become yet, but I hope it does. Wherein a recipe can be broken down into rules, rule number 1, rule number 2, rule number 3, which I won't get into the technicalities now, and build a sentence which is recursive. Most of the recipes that we cook today are having a phenomenon of recursion. One of the ingredients that you are using is already a recipe in its own self. So there is a powerful recursion that is coming in. Those who know programming and logic will understand what's the power of recursion. Okay? So with that, we should be able to create recipes that are innumerous, literally speaking, following the rules of the grammar of cooking. We can do that. This is one such recipe, Italian potato salad, very simple one. Students sitting in the hall thinking, how many marks did I lose out of those 8 marks because of this nasty question that I had to answer. Sorry for that. But this question was asked in this computational gastronomy end-sem examination. And this is the answer, by the way. You can tell your answer if you wish right now. Okay, so with this, what are we doing here? This is like very fundamental, basic, philosophical. Is there a structure to what we speak, language? Is there a structure to what we cook? Cooking. That's what we're doing. And this gentleman, Noam Chomsky, 95 years old, MIT Emeritus Professor, considered to be the Einstein of social sciences, wrote back after reading the paper saying that interesting idea. That's good enough. That made my day for sure on that day. Alright? So to end my talk, we are asking this question, and my proposition before we rush to the conclusion, though very humbly and modestly Chef Gill said that maybe computer can actually think better than me. I don't think so, sir. I don't think so, sir. Whether it is Chef Bali or Chef Akshay, I don't think so. What I believe is this. Maybe we are not in the endeavor using artificial intelligence to replace chefs, to replace my mother, or to replace anybody who knows cooking. No. Probably what we are doing through my company that we are launching is to build a co-pilot, AI co-pilot for a chef to help think better, to help organize better, to innovate better. Can we do that? Can it be an enabler, not a replacement? So that's what we are trying to do, and we hope we should be able to do it with the help of all of you guys who are in the room, and some of you might take new ideas, develop entrepreneurship, create companies, which is what our endeavor is. Those of you who do not know about my background, I am trained in physics to begin with, and I had this aspiration of becoming an astronomer as a teenager, nothing else. It's been a journey from astronomy to gastronomy, to make a pun out of it. And to take this quote from Brilla Sadrin, who wrote the book The Physiology of the Taste way back, 150 years back, more than that, who coined the term in the first place, gastronomy, incidentally, that the discovery of a new dish confers more happiness on humanity than the discovery of a new star. So I'm relieved. I'll be doing something good for the community and society, if not live my teenage dream. So I'm hoping to create new recipes which are tasty, healthy, nutritious and sustainable to help build a better future for today's world as well as tomorrow's generation. That's what I'm trying to do. So thanks a lot for being part of this program.